Today we're going to start solving exponential equations, and eventually we'll get to solving log equations. So when we solve these exponential equations today, our goal is to try to make them be the same base. That's going to be the method that we use. So let's take a look at example 1. We're going to try to solve that equation. We're going to try to solve and see what x equals. In order to do that, we want to try to make both bases be the same. The left side has base 3 and the right side has base 27. So we know that 27 is actually 3 to the third power. So let's rewrite both sides. So 3 to the 2x equals, and 27 is really 3 to the third power. Put that in parentheses and leave the x plus 1 as the exponent. All right, let's simplify from here. So 3 to the 2x equals, and then when we have a power to another power, we multiply. So we're going to distribute this. So it becomes 3 to the 3x plus 3 power. Be very careful of this one right here, this 3. Don't forget to distribute to both. Now that the bases are the same, so the both bases are 3, if this equation is really true, if these are equal to each other, then the exponents must be equal as well. So I'm just going to set the exponents equal now. And now we just solve for x. So I'm subtracting 3x on both sides to get negative 1x equals 3. Divide by negative 1, x equals negative 3. So if we were to go back into that original equation and substitute negative 3, and for the x's, then it would make the equation true. So x equals negative 3. All right, so in example 2, we're going to do the same thing. So our goal is to try to make the bases the same. Now, just so you know, this won't always be able to happen, but I'll show you what to do in the next video if you can't make the bases the same. All right, so I've got base of 2 on the left side, and on the right side I have base 16. So I know that 16 is actually 2 to the 4th power. And use your calculator if you don't remember some of those. So the left side stays 2 to the x minus 1, and the right side becomes 2 to the 4th, and then to the x plus 3 power. So we simplify and get 2 to the, and we're multiplying, so we're distributing. Don't forget to distribute to both. 4x plus 12. And since the bases are the same, that means the exponents must be equal as well. Almost think of it as like crossing out the bases. And then we solve for x. So we get rid of one of the x's. So negative 1 equals 3x plus 12. Subtract 12. Negative 13 equals 3x, and divide by 3. So x equals negative 13 over 3. I mean, you could get a decimal answer, but why get the calculator out when you don't have to? So this would be your final answer. All right, let's look at example 3. So in example 3, still trying to make the bases the same. So I have one base is 4 and the other base is 8. So in my other problems, I looked for the bigger number and tried to make it the smaller number to a power. So 8 is 4 to some power. Well, 4 to the first is 4, and 4 to the second is 16, so no. So in this problem, I'm going to have to change both bases. So I can write both 4 and 8 with base 2. 4 is 2 squared. Keep your 3x outside the exponent. 8 is 2 to the third. Keep your x plus 1, and now we'll just have to multiply them both. So 2 to the 6x equals 2 to the 3x plus 3. And again, your bases are the same, so the exponents must be equal. Solve for x. So get rid of one of the x's. So 3x equals 3, divide. So x equals 1. All right, example 4. So let's again take a look. So can we write 32 as 8 to some power? Well, 8 to the first is 8, 8 to the second is 64, so no. So that means we're going to have to change both of them. So I can write 8 as 2 to the third. So can I do the same with 32? If I check on my calculator, 32 is 2 to the 5th power. And 8 we said was 2 to the third. Keep the x minus 1. So I have 2 to the 5th equals 2 to the 3x minus 3. So the exponents must be equal. And we solve for x. I'm going to add 3. And then I'm going to divide by 3. So we get that x equals 8/3. All right, last two examples. So in these problems, notice we don't just have bases to exponents, we have things being multiplied in front and things being added and subtracted. So first thing, before we can make any bases the same, is we need to make it look like the other problem. So it needs to look like a base to some power. So we have to get rid of those extra numbers. So in number 5 here, we're going to subtract 2 first. So we get negative 1/3 times 3 to the 2x equals, because this cancels, negative 9. To get rid of the negative 1/3, you could divide by negative 1/3, but it has to be in parentheses if you choose to do it that way. Otherwise, we multiply by the reciprocal. So that cancels, and negative times a negative is positive. So we get 3 to the 2x power equals negative 9 times negative 3 over 1 is positive 27. And now that all those extra numbers are gone, we just have bases with exponents. So we try to write them both with the same base. So I know that 27 is 3 to the 3rd power. The other side already had a base of 3. So when we cancel those, or we say the exponents are equal, divide by 2, so x equals 3 over 2. You'll see your answers as fractions for these problems. All right, for example 6, last example, same thing. I see some numbers outside of my base to the power. So I'm going to add 7 on both sides. So 3 times 2 to the 4x power equals 24. I'm going to get rid of that 3 in front, divide by 3. So 2 to the 4x power equals 8. And again, I need to make my bases the same. So 8 is 2 to the 3rd power. That means the exponents must be equal. Divide, so x equals 3/4. And just to end the video, here are the step-by-step directions of what we did. And you can pause it and write it down if you would like.